Good afternoon once again. Let us complete this chapter today. Then we'll left the last chapter in our syllabus volume and surface area. We are starting with this question in a minute. Let the students get join. By the time those who have not written this, they can write it down. Starting with the solution now. By far, we have studied this, that OA is 20 centimeters. So we have calculated this diagonal. Now this diagonal is 20 root 2 with the help of this direct formula, root 2 multiplied by side, diagonal of square. As the diagonal of the square is 20 root 2, so therefore the radius of this quadrant is also 20 root 2. So area of shaded region is equals to area of quadrant OPBQ minus area of square. So area of quadrant again is 1/4 of pi r square minus area of square is side into side. So 1/4 into 22/7, 3.14 we need to use here. If it is mentioned in question to use 3.14, then we will use that. Then r is 20 root 2 square minus 20 into 20. So 1/4 into 3.14 into 20 root 2 square for 800. 20 square is 400. 400 into 2, 800 minus this 400, cancel it. So it is 628 minus 400. So the answer is 228 centimeter square. Note it down. 13th question. This is the solution for this question. The last two, now we'll move to the 14th question. How many questions are there? 16 questions are there. Okay. Note it down, be quick. Question number 14. Just wait. AB and CD are two arcs. AB and CD are two arcs which helps in making the sector. COD is the smaller sector and AOB is the bigger sector. No, it is how we can calculate the shaded region, area of bigger sector minus area of smaller sector. So it's a very simple question that I think we have done a question like this before in this exercise. So angle is already given, that is 30 degree, and two radii are given, r being the radius, capital R represents the radius of sector AOB, that is 21 centimeter, and small r represents the radius of the smaller sector, that is COD, 7 centimeter. Then area of shaded region, that is area of sector AOB minus, we should write here the word sector also, minus area of sector COD. So that is pi capital R square into theta by 360 minus pi small r square into theta by 360. Pi theta by 360 you can take common. Inside it will left with r square minus r square. So just put the value 22 by 7 into 30 by 360, then 21 square minus 7 square cancels out, 11 by 42 into 441 minus 49. So 11 by 42 into with 2 we can cut this, 196, then by 7 2 the 14, then 8 the 56, 7. Now 308 by 3 centimeter square. Note it down. This is the solution. Now the last two questions are very important. Mark them important. Question number 15 and 16. These two questions have repeated also a number of times, so mark it. The next. See this. ABC is a quadrant of a circle of radius 14 centimeter. ABC is a quadrant. So ABC is a triangle and ABC is a quadrant also. How? See this line? This is a quadrant. So ABC is a quadrant. And this on BC there is a semicircle. See this? This is a circle made on BC. So this is a semicircle this side. It was just made to make you clear with the figure. Okay, so this ABC, ABC means from here till here, all is this is quadrant, and the other is semicircle, and one is triangle. So these are the three things given in this question, and it is mentioned even in the question also. And the quadrant has a radius 14. So radius of quadrant is this 14 centimeter. Same here 14. And a semicircle is drawn. A semicircle is drawn by taking BC as diameter. So BC is the diameter of this semicircle. Let it be O. Okay. Let here be one of the point D. And let here be one of the point E. Right. Radius of quadrant represented by letter capital R is 14 centimeter. So radius of quadrant is given, but radius of this semicircle is not given, which is required to find out this shaded area. So how we can do that? See, this is a quadrant. So therefore angle A is 90. Angle A is 90 by Pythagoras theorem, which we can use in triangle ABC to find out this BC. Okay, so h square is equal to p square plus b square. H is this BC and P is AB and base is AC. So AB is 14 square plus AC is also 14 square. 14 square plus 14 square means 196 plus 196. Or see, the easy way of doing this part is this. See how we can do this. 14 square are 2 times. So we can write 2 into 14 squares. 14 square because it is in addition. So BC is equal to under root 2 into 14 square. Where 14 has a square, so it will come out of the root and 2 will remain inside. So 14 root 2 centimeter is BC. So what is BC? 14 root 2 centimeter. So if BC is 14 root 2 centimeter, then radius of semicircle is 14 root 2 divided by 2. That is 7 root 2 centimeter. So this radius is 7 root 2. Now how to find out the shaded region? We have to find area of triangle, then area of semicircle, then out of area of triangle and area of semicircle, we have to subtract this quadrant. See this area of triangle so area of triangle, and in the same way area of semicircle. So this is full semicircle. So with the help of area of triangle and area of semicircle, we will be able to find out the area of full figure, because after triangle semicircle starts. Okay, so this full area will come. Out of this full area, we have to subtract this light green colored quadrant. So this quadrant we have to subtract then. To find out the shaded region. And shaded region is this one. Okay, I hope it is clear. Write it down. Area of shaded region is equal to area of triangle ABC plus area of semicircle BEC minus area of quadrant ACDB. So area of triangle, half into base into height, plus area of semicircle, that is pi r square by 2. Area of quadrant is pi r square by 4. Put the values half into base into height, 14 into 14 plus 22 by 7 into radius. Radius of the semicircle is 7 root 2 into 7 root 2 upon 2, then minus 22 by 7. into the radius of this quadrant is 14 into 14, 7, and this cancels out. And with this 2, root 2 and root 2 cancels out because root 2 into root 2, 2. That's why. And this 7 and 7 also cancels out. And with this 2 and 7. So all the denominators are cancelled. It is 98 plus 154 minus, I think here I have not written 4. This 4 will also cut like this. So 154. This cancels out. So the answer is 98 centimeter square. Don't leave the examples of this chapter. Examples are equally very important, especially of this exercise. The examples given before this exercise are very important. Do each and every example, okay, in your practice notebook. And the last and the most important question, 16. Note it down. I'm giving you 1 minute to write this. Next now, so let us begin with this question, number 16. Calculate the area of design region in common between the two quadrants of circle of radius 8 centimeter each. You need to understand this, how it is being made. There is one quadrant. This is one of the quadrant which is made. Then from that side, one more quadrant is made like this. Means from the other side also, quadrant is made this way, means from here and from here. So these two quadrants are joined together, and there is a common thing. This is a common area in between. We have to find this, the designed area. So the design region we have to calculate. So for this, how to do? Area of this quadrant first. Let's try to understand. This shaded region is the quadrant. Fine. Now I'm shading from the other side. That is also a quadrant. Now see this. This is also a quadrant from that side. Both the side it is 90-90, and this is a square. Okay. So this is a square that is clearly visible because all the sides are equal and the angles are 90. And but it is not mentioned in the question, but we have to consider it as a square, as in the figure it is clearly visible. Now from here also we have a quadrant, and from that side also we have a quadrant. Add these both quadrants. If you will add both the quadrants, then you will be able to get this area, then this area. And if you are adding both area of both the quadrants, so let me make it more easy. Let this area be first, and this designed area be second, and this green, light green area be third. When you will calculate area of this quadrant, let me give a name, A, B, C, D. If you are calculating area of this quadrant A, B, C, then you are calculating first plus second area. Yes, no, first and second region. If you are calculating, there is no triangle formed. Ankur is saying area of sector minus area of triangle. No, that is not. Please try to understand this. Now, if you are calculating area of quadrant, then you are calculating these two regions, this orange and this dark green part, first and second. And if you are calculating this quadrant, then it means you are involving two areas, second and third. Fine. Means after adding the area of this quadrant and area of this quadrant, you will get this much. Okay. Now, no, Abhishek, there is no need of diagonal also. See, it is very easy. Area of this quadrant plus area of this quadrant will get this much area. Yes or no? Abhishek, just tell me yes or no. Is it clear? 1, 2, 2, 3. While calculating this quadrant, first and second part will get. While calculating this quadrant, we'll get second and third part. Yes. Now I want to subtract the area of square from this sum. See how to, I am subtracting the area of square. I am subtracting the area of square. Full. This full I am subtracting. If I'll subtract this full, then first, second and third, all the three areas will get subtracted. Yes, no? All the three areas will get subtracted. It means this, and this will get subtracted. But we will left with the second region still, which is the designed area. It means how to solve this question? Area of first quadrant plus area of second quadrant. Now come back to the original color. Area of first quadrant plus area of second quadrant minus area of square will get the answer clearly. Were you clear by this? First, second, and third. So just write first radius of each quadrant is 8 centimeter and side of square is 8 centimeter. Area of designed region is equal to area of quadrant ABC plus area of quadrant ACD minus area of square. Now area of quadrant ABC, that is pi r square by 4, plus area of quadrant ACD, that is pi r square by 4. R is same in both cases, minus area of square side into side. So pi r square by 4 plus pi r square by 4 will be 2 pi r square by 4, which is this way cancelled out. Now put the values. 22 by 7 into 8 into 8 by 2 minus 8 into 8, 2 and this cancels out. So 22 into 32 by 7 minus 64, taking LCM. 3222 minus 448 by 7 . There is some error, I guess, somewhere. 22 by 7 into 8 into 8 by 2, 432. It is 7. This I don't know how I have written this. 704 it is. Minus 448 upon 7. Now after subtracting the 2, we'll get 256 by 7. Is it clear? This question is very easy, but you need to understand the figure. I can explain you one more time. Area of quadrant ABC. If you are calculating area of quadrant ABC, then we include first and second part. And if we are adding area of quadrant ACD, then it includes second and third part. If we are adding both the quadrants, then after subtracting area of square, then first, second, and third, all the parts will get subtract. But still second part will left. That is the designed reason. Put it down. With this question, the chapter gets over. Tomorrow is Friday. Tomorrow we are going to start with the next chapter, volume and surface area. And tomorrow we'll be focusing on understanding of the formulas related to the shapes given in volume and surface area. Okay, so tomorrow the lecture will be based on discussion of formulas and understanding of the formulas and how the formulas are made and all. Okay, so that it will be easy for you to understand chapter number 13. Bye, and there will be tomorrow, and there will be only one lecture tomorrow. Okay, so bye, take care. Too much you have studied today. The lecture is over. And complete this chapter in your notebook and keep sending me your PDFs, okay, of each and every chapter the moment you are completing it. Bye.